are in a new section, and this is a section on launchers. I'm very sure that you've heard terms like PSLV and GSLV. Very recently, terms like GSLV Mark III has been in news last 3-4 years of time. Whenever a new launch happens, you might come across terms like PSLV C37, PSLV C48, PSLV C49, PSLV C41, GSLV Mark II, GSLV this and that. So all these kind of terms often come in news. So what we are going to learn in this section is about all the launchers that India has and the various terminologies which are associated with all these launchers. First of all, what do we mean by a launcher? What is the meaning of a launcher? Until now, we have been discussing about how satellites are launched, what is the basics of science behind launching of any satellite, what are the applications of different satellites, what are the names of different kinds of satellites that India has. We have been discussing all that. Now we come to how do we launch a satellite. That is, what is the entire infrastructure behind launching a satellite. So for launching any satellite, we need something which is called as a satellite launcher. So this is precisely what we are going to discuss in this chapter. Now when we talk about launchers of India, if you look at the screen and all the things that you have on the screen, these are the various launchers that we have seen in India. Starting from SLV3, which was our very first launcher, to coming to GSLV Mark III, which has been the recent addition to the list of launchers that India has. So let's try and understand what are these launchers, what are the different kinds of launchers that India has. So first of all, we begin with the different kinds of launchers that India has seen. So for the purpose of understanding the things and classifying in a better manner, we classify them into three parts. One, all the historic launchers, then after that all the operational launchers, and then the launchers of the future. So first of all, there are two names in the historic launchers, SLV, or better known as SLV3, and then we have ASLV. SLV simply stands for Satellite Launch Vehicle, and ASLV stands for Augmented Satellite Launch Vehicle. So these two were the first two launchers that India had. SLV3 was the very first launcher when we started to develop our own capacity to launch a satellite. Before SLV3, the satellites that we used to launch, these were the satellites which usually were being launched from Russia. For example, Aryabhat. Aryabhat was a satellite that we launched in 1975, and this was a satellite that was launched from Russia and not from India. So SLV3 became our very first launch vehicle. Although this was not a launch vehicle which could be used for practical purposes, because most of the satellites were very heavy. The ones which were being launched, they were heavy satellites, and SLV3 did not have a capacity to launch these satellites. So if you look at this picture, the height of this satellite launch vehicle was 22.7 meters, the lift-off weight being 17 tons, the payload mass being 40 kg, and the orbit being low Earth orbit. So payload mass was the big problem, 40 kg of satellite. We have discussed the various kinds of satellites, and 40 kg is the mass of a satellite which comes under micro satellites, right? So micro satellites were not very usable at that point of time. We did not have a capacity to launch a satellite which is very compact. So there was no possibility that these kind of satellites that we were launching then, for example, most of the communication satellites that were being launched, the communication satellites normally weighed in the range of 4,000 to 5,000 kg. So 40 kg was nothing. But the silver lining is that this was the first launch vehicle. This is where we started to build our own infrastructure, our own capacity to launch a satellite. So this was SLV3, our very first launch vehicle. Then came ASLV. ASLV, we saw that with ASLV the payload mass increased to 150 kg. That now 150 kg of satellite can be launched using a launch vehicle produced in India. But even 150 kg does not serve the purpose. 150 kg is also not as much as it is required to launch a normal remote sensing satellite or going forward the communication satellites. So that's why even this, although we increased the capacity, we were going in the right direction, but still we did not have the capacity to launch the satellites that we usually need. Then comes PSLV. Now PSLV is where we come to the operational phase. This is where we see that we come to the launch vehicles that are even being used today. So we have three in this category: PSLV, GSLV and sounding rockets. So operationally you will see that today all these three are being used. PSLV is very often being used, GSLV is also used for some purposes, and sounding rockets also are being used. Even in 2020, we have seen all these launches. There was one sounding rocket test that was done. There was PSLV C49 that was launched. So we have seen that all these launches have happened in 2020 as well. So that's why this is called as the operational phase. We have three different kinds of satellite launch vehicles here: PSLV, GSLV, and sounding rockets. So let's try and understand all these three one by one, starting with sounding rockets. So when we talk about sounding rockets, these are one or two stage solid propellant rockets. So you have couple of terms here. One is stage and second is propellant. And there is another third term that you have come across until now, and that is the term payload, right? So let's try and understand what is the meaning of these three terms. First is stage, second is propellant, and third is payload. So when we say that a sounding rocket has one or two stages, it means that one stage means that there is one compartment where the fuel is being stored, fuel along with its oxidizers. And when we say two stages, it means that there are two components, there are two compartments where this fuel is being stored. Similarly, when you go to PSLV, PSLV has four stages. What's the meaning of four stages? That there are four compartments in which the fuel is being stored in the launch vehicle. So these terms like one stage, two stage, three stage, etc., whenever you come across any launch of a satellite that happens, or even in terms of missiles. In terms of missiles also, when we discuss about missiles, we'll come across these terms again. Stages of a launch vehicle or stages of a missile. So this is what it means. Then after that you have propellant. Propellant is nothing but the fuel that is being used. For example, our cars and scooters run on a liquid propellant, petrol and diesel. So petrol and diesel being the liquid form of petroleum, they are called as liquid propellants. Similarly, when we talk about solid propellants, these are the fuels which are solid. So this is what exactly it means. Then after that, you have another term which is called as payload. Payload is nothing but the carrying capacity of a launch vehicle. A launch vehicle has its own components plus the fuel plus the oxidizers. When you subtract all that, when you have only the satellite, the components along with the satellites which are going, if it is a manned mission, then the weight of the people who are on board. When you take the weight of all these, this is what is called as the payload. So for example, if you talk about your car, so in your car, once the car is empty, when you have nothing inside the car, then it is empty. Once you all sit inside, once let's say you load everything that you are carrying along with you, then in that case all these things, all the luggage that you have plus the people who are sitting inside the car, that becomes the payload of the car. Similarly, for a launch vehicle, every component, the satellite itself, all the sensors, etc., all these things combined are called as the payload of a satellite. So when you come across these terms, just understand what exactly we mean by these terms. So there are three different kinds of launch vehicles that we have. You have RH200, you have RH300 Mark II, and you have RH560 Mark II. First of all, the payload carrying capacity: RH200 10 kg, RH300 60 kg, and RH560 100 kg. Then altitude, the height up to which they can go: 80, 160 and 470. Main purpose for which they are being used: meteorology for RH200 and aeronomy for RH300 and RH560. And then after that, the launch pad which is being used for RH200, Thumba is being used, and for RH300 and 560, Sriharikota is being used. So this is a basic comparison between the different kinds of sounding rockets. So what are sounding rockets? Sounding rockets are the ones which are usually used for experimental purposes. The kinds of launch vehicles which cannot carry a heavy satellite, as you can see in the table that you have on the screen, that it is not used for a very heavy satellite. It is used for experimental purposes, when you don't have to go much beyond the atmosphere and you just need to conduct an experiment. For all these purposes, we use sounding rockets. Making sounding rockets does not take a lot of time, it does not take a lot of effort, it does not take a lot of money. So involvement of time and money is less. It saves a lot of time and money, and that's why whenever the purpose is not launching a satellite which is huge, which is going to go into beyond the Earth's atmosphere, in that case we'll see that most of the cases sounding rockets will be used. Very recently, I'm sure that you have come across this news that RH200 was actually tested also. Very recently, RH200 was tested with a new kind of fuel. So basically we are talking about the two-stage fuels here, two kinds of fuels that are used, two stages in which the fuels are used. So if this is the rocket, then you have the two stages like this. These are two compartments where you carry the solid fuel. Very recently it was in news that RH200 was tested with a new fuel. Normally the fuel that is being used here is PVC or polyvinyl chloride. Normally what we are using here is polyvinyl chloride. This time, for the first time, they have used HTPB as the fuel. HTPB is hydroxyl terminated polybutadiene. If you just want, I can write it down here. Hydroxyl terminated polybutadiene. So this is something that was tested, I think, September 2020. Last week the test had happened and it was a successful test for RH200. So just remember these of few of the facts because this becomes a part of your current affairs as well. Then after that we come to PSLV. So PSLV has been the most successful launch vehicle that India has had. PSLV has also been named as workhorse of ISRO. And why it has been named as workhorse of ISRO is because of the success that it has had. Most of the success that ISRO has been attributed to, it has come because of the success of PSLV. A lot of launches that we have done over a decade, more than a decade rather, all the launches have been successful. Between 2008 to 2018, there have been more than 40 launches which were successful on the trot without a single failure. Only one failure happened at the end of 2018 when they were trying to launch a Navig satellite. That was the first time in a decade that a PSLV failed. So such stability has been seen with PSLV, and that's why PSLV has gained a lot of market internationally as well. We have seen that a lot of launches that ISRO has been doing, ISRO has been launching a lot of foreign satellites as well. We took an example of 104 satellites being launched in PSLV C37, right? So in PSLV C37, the 104 satellites that were launched, out of them only 3 satellites were Indian. There were only 3 Indian satellites. One was a Cartosat series satellite, and then you had INS-1A and INS-1B. Apart from that, a total of 101 satellites were foreign satellites. Out of these, 95 satellites were just from the USA. So because of all that, we have seen that ISRO has gained a lot of success and it also has generated a lot of revenue. So a large amount of revenue that has been generated from international assignments by ISRO has been because of PSLV. So out of all its products and services, PSLV has been the most successful for ISRO. And that's why we have seen that a lot of governments and lot of agencies from abroad also have come to ISRO and have gotten their satellites launched. And fact of the matter is that PSLV has been very successful, has been very stable, at the same time has been one of the cheapest. If I just give you a comparison shows that if you do a normal launch using an Ariane 5 or an Ariane 6 launch vehicle of France, it costs approximately $90 million. It costs approximately $90 million. Compare that to PSLV. If you talk about a PSLV launch, what we have observed is that a normal PSLV launch just costs approximately $15 million. So that's a huge difference. So that's why because of this particular difference, we have seen that a lot of foreign agencies and the governments have been coming to India to get their satellites launched. So first of all, what do we mean by PSLV? PSLV simply stands for Polar Satellite Launch Vehicle. So Polar Satellite Launch Vehicle means what? It means that most of the launches that are being done by PSLV, they are being done for the polar orbits. What are the things which are there in polar orbits? If you just try to recall, we discussed about Earth observation satellites. We discussed that Earth observation satellites are launched either in polar orbits or they are launched in sun synchronous orbit, which is also a special case of polar orbit, right? So most of the launches which are being done using a PSLV, they are being done for a polar orbit or a sun synchronous orbit. But it's not that it's restricted to only these two. For example, if you go back in time and look at the launches like Chandrayaan-1 or the very famous Mangalyaan, even these two were launched using a PSLV. A variant of PSLV was used to launch these as well. So we have seen that PSLV has been largely successful, and that's why many a times for these kind of launches also we have been using PSLV. So Where will we use PSLV? One, when you have an Earth observation satellite or a remote sensing satellite being launched, then you will use PSLV. Then in some of the cases where we are going beyond the polar orbit also, but the satellite weight is not very high. If let's say the satellite weight is in the range of 1000 to 1500 kgs, less than 1500 kg most of the times, then in that case there is a possibility that we can use PSLV. But if the satellite weight is high, if the payload weight let's say goes beyond 1600, 1800, beyond 2000 kgs, then in that case we see that PSLV cannot be used. So PSLV does not have a carrying capacity beyond approximately 1500 to 1600 kg. In that case we need to use another launch vehicle. So this is what we have been seeing with PSLV. So first of all, PSLV is the third generation of launch vehicles after SLV and ASLV. The first Indian launch vehicle to be equipped with liquid stages. So when we discussed sounding rockets, we have discussed that it is a solid propellant launch vehicle. So it does not carry any liquid propellant. Even with the very recent launch also, we discussed this, that instead of polyvinyl chloride, now they are using HTPB. Both are solid fuels. So liquid fuel is not being used in sounding rockets or the second and the first generation launch vehicles that we have. So with this PSLV, the third generation of launch vehicles, this is the first time that we started to use liquid stages. Liquid stages has its own advantages and we'll have a discussion on that. Now let's try and understand what exactly PSLV is and little bit of technicalities behind PSLV. So what you look at on your screen is how a normal PSLV looks like. So if you dissect the PSLV launch vehicle, first of all, there are 4 stages. We discussed what stages are. So here you have 4 stages, and these 4 stages, as you can see here, these are the 4 stages that you have. If I just have to draw a simpler diagram, let's say, then in that case I would say that it looks something like this. That you have a satellite and then you have 4 stages. So let's say you have something like this. Now all these stages that you have, as you can see, you have the first stage, you have the second stage, you have the third, and you have the fourth stage. Fourth stage is here, this part is third, this is the second stage, and this is the first stage. So now these are the stages where the fuel is stored. For example, in case of a PSLV, the first stage carries HTPB. We just discussed about HTPB while discussing the sounding rockets as well. So this is what? This is a solid fuel. Then after that you have the second stage. Second stage is where you have a liquid fuel. You carry a liquid fuel here, and this liquid fuel is called as UDMH or unsymmetrical dimethyl hydrazine. The name is, if you just want to know, unsymmetrical dimethyl hydrazine. This is the name of this fuel which is carried in the second stage. Then after that we again have the third stage where the propellant again is HTPB. Then after that, when you go to the fourth stage, you have 2 propellants here. One which is called as MMH. MMH is nothing but monomethyl hydrazine. So instead of unsymmetrical dimethyl hydrazine, now you have monomethyl hydrazine. So this is the fuel which is carried in the fourth stage. Now the question comes, why are we using this combination? Why starting with the solid fuel then going to the liquid fuel? So what happens is, when you are on the surface of the earth, when this satellite is being launched, at this point of time the force of gravitation is very, very high. The gravity of the earth that the satellite launch vehicles come across, they are very, very high. And because this force is very high, the magnitude of this force being very high, it needs a lot of thrust to overcome that force. So to overcome that force, a large amount of thrust is required. And what we know is that solid fuels always give you higher amount of thrust as compared to a liquid fuel. So that's why the first stage will never have a liquid fuel. First stage will always have a solid fuel. Now, the problem with solid fuel is that controlling the flow of solid fuel is not very easy. So for that very matter, we need liquid fuels to come at a later stage. So that's why, for example, if you take your cars and scooters or bikes, when you have petrol and diesel, you know that very easily through the pipes, you can control the amount of fuel that is to come to the engine, right? But if it was a solid fuel, then it might have been very, very difficult. So that's why for that very purpose, if you just generalize the same thing into a rocket as well, and you take it as an analogy, you can understand that why liquid fuel will be required at a later stage. Also, what happens is, once you start to go to the second, third and the fourth stages, the amount of propellant that is required also decreases. So for example, the first stage needs the largest amount of fuel as compared to the second or the third or the fourth stage. So these are the four stages that you have where solid and liquid fuels are stored. Then after that you also have something which is called as strap-ons or strap-on motors. So these structures that you see, these small structures that you see, these are also called as strap-on motors. So these strap-on motors provide the extra amount of thrust that might be required. So the extra thrust that is required by the launch vehicle to move forward, to go into the space, this is provided by the extra strap-on motors. So that's the role of the extra motors that are provided, the small rocket-like structures that you see here. So what do you see? You have the four stages. On these four stages, you have the fuel. Along with the fuel, an oxidizer is also being carried. Why do we need the oxidizer? Oxidizer will help in burning the fuel. For example, even if you have to light a simple matchstick, so that matchstick also is burning, undergoes combustion only because there is oxygen in our atmosphere. If there was no oxygen in the atmosphere, the matchstick will not burn. The matchstick will not light up because there was no oxygen in the atmosphere. So oxygen basically acts as an oxidizer. It helps in combustion. So similarly, you also need to carry some oxidizers in the launch vehicle as well, so that it helps in burning of the fuel. So these oxidizers, as you can see here, you have N2O4 here and you have MON here. So MON3 or N2O4, N2O4 is dinitrogen tetroxide and MON is mixtures of oxides of nitrogen. Mixture of oxides of nitrogen. So in the second stage, dinitrogen tetroxide is being used, and in the fourth stage, a combination of nitrogen oxides is being used. For example, nitric oxide, nitrous oxide, dinitrogen tetroxide, all these are used as a combination. So that's why it is called as mixture of oxides of nitrogen. So mixture of nitrogen oxides is being used as oxidizer in the fourth stage, and in the second stage you are using dinitrogen tetroxide. Now, so these are the four stages. After that, you have this part where you are carrying the satellite, where you are carrying the payload basically. You are carrying the payload here. So these are called as payload fairings. Payload fairings are the ones which is protecting the payload which is kept inside the structure. So if you go back to the news where for the first time in a decade, we saw that there was a failure of PSLV while trying to launch one of the Navik satellites, one of the IRNSS satellites. That failure happened because the payload fairings did not open. At that point of time, the payload fairings did not open, and that's why it was a failure. Otherwise, before that, for a decade, we saw that there was no failure that any PSLV launch vehicle saw. So this is a basic about what PSLV looks like. Now there are many variants of PSLV. You will come across many variants that have been used from time to time. And if you look at all the data with respect to all these payloads, you will come across different kinds of PSLV. You have PSLV CA, you have PSLV G, you have PSLV XL, DL and QL. These are the 5 different kinds of launch vehicles that PSLV has. So if you look at the data that we have on the screen, this is a data of all the different kinds of launch vehicles that we have been using since the time PSLV has been in use. So for example, if you see the beginning, you will see that we started with PSLV G, and up to 2007 we were mostly using PSLV G. G here stood for PSLV generic version, or it was also called as the standard variant. This was the PSLV standard variant or the generic version. Now this is one variant that has been discontinued. You will see that the last launch for G that happened, it was back in 2016, and after 2016 PSLV G has not been used. Then after that we have the PSLV CA variant. Here CA basically stands for core alone. It stands for core alone variant. Why it's called as core alone is that at the base where you saw all these strap-on motors, if you go back to this picture, these strap-on motors, they are not available in the CA version. The core alone variant does not have the strap-on motors, and that's why it is called as core alone, because the core does not have any of the strap-on motors. So that's why this is called as the CA variant. Then you have the XL variant. XL variant is the biggest variant which can carry larger amount of payload as compared to the other variants. So as you see, 2008 was the first time when XL was used, and this basically was for Chandrayaan 1. For the first time XL variant was used, and then after that you will see that in the last few years the use of XL variant has increased a lot. 2016 specifically, you can see that all the launches apart from one generic version launch, all the other launches were PSLV XL launch. So these have been the three which have been in news widely. Now you will see that there are two new variants that have been introduced since 2019. The launches that have happened in 2019 and in 2020, we have seen that they have happened with the help of PSLV DL and PSLV QL. These are the two new variants that have been introduced. For example, the last launch that happened in 2020, this was done using PSLV DL. Similarly, you will see that two launches in 2019 also happened with the help of PSLV QL. So these are two new variants that have been introduced by ISRO. Now let's have a look at all the comparison points between all the different variants of PSLV that we have. You have the CA or the core alone variant, you have the generic or the standard variant, you have the XL variant, which is the largest and the heaviest of them all, and then you have DL and you have QL, which are the newer variants that have been introduced since 2019. So height wise, it's all the same for all the variants, that is 44.4 meters. Then lift off mass, where you will see the first difference. Lift off mass of CA is the least, that is 230 tons, and it is the most for the XL variant, that is 316 tons. Then the number of stages, being all the compartments of fuels, are the same, 4 stages for all of them. The LEO payload, that is the payload that it can carry up to the low Earth orbit. So that payload in case of CA variant is 1019, a maximum of 1019. G variant 1600 kg, XL 1673, DL 1257 and QL 1523. Then GTO payload, that is the amount of payload that it can carry to GTO or geosynchronous transfer orbit, if let's say the orbit is going to be beyond it. If the orbit has to be GSO like geosynchronous or geostationary orbit, or if it is something which is launched for any other celestial body like moon, Mars, etc. So in that case, PSLV CA is not capable because of the fact that it is core alone variant, meaning that it does not have the extra amount of thrust. So that's why it will not be able to carry payload to GTO. Similarly, for DL also we see the same thing, that DL will not be able to carry payload to GTO. For PSLV G, it was 1100 kg, approximately 1100 kg. PSLV XL, it is 1425 kg. For PSLV QL, there is no official figure that has been given by ISRO yet. We have not seen any launch also happen for GTO, and there is no official figure that has been given. That's why I've left it blank for now. Strap-on motors. This is the main reason for the difference between the different kinds of variants that we have for PSLV. So there is no strap-on motor in XL variant. There is no strap-on motor. That is why it cannot carry payload to GTO. Then in PSLV G, we had 6 payloads of S9 variant. S9 means basically that it can provide a thrust of 9 tons. A total thrust of 9 tons can be provided by each of these motors, and there are 6 such motors which are available in G variant. Then after that XL variant, there are 6 motors of S12 variant, that is 12 tons of thrust can be provided by each of the strap-on motor. Then after that in DL you have 2 such motors of S12 variant, and for QL you have 4 such motors of S12 variant. So this is a basic comparison point between the different kinds of launch vehicles. It may not come directly in your examination, but in your prelims examination, if a question comes related to the launch vehicle that was used or how much of weight could have been carried, all that can be answered if you understand this. So for example, a very large, very heavy satellite cannot be carried with the help of a CA variant launch vehicle, because that launch vehicle does not have capacity to launch satellites which are massive. Similarly, if it is heavy satellite, for example, it's Mangalyaan or Chandrayaan or Astrosat, you definitely would be using the XL variant and you won't be using the CA variant or QL or DL variants, because these are variants which cannot carry that much amount of mass. They are lower in amount of mass that they can carry. So all these kind of hints you will get from this comparison points, even if it does not come directly in the examination. But since we normally see that every time there is a launch, they will mention terms like DL, QL, etc. So that's why you should know what are the meanings of all these terms. So the latest launches that have been happening in 2019 and 20, we have seen that in 2019 there were two QL launches that happened. There was one Excel launch, there was one CA launch, and there was one DL launch that happened. And 2020 we did not see a lot of launch happening. There has been only one launch that has happened for the DL variant. Because of the pandemic situation in 2020, we did not see a lot of new launches happening with these launch vehicles. So this is what you have in PSL.